Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we have completed GATE 1993. Today we will start 1994, and I'll try to upload 1994 in two videos, section A and section B. So without wasting time, we will look into the question. Okay, so very first question is the inverse of matrix A is 0 0 B. So we know that for 2 cross 2 matrix, here is the formula. Suppose if I have a B C D, I have this matrix. Any A B C D can be anything. So A D minus B C, D and A will interchange the places, and B and C will become negative, but the place remains same. So similarly, if I take this example, A0 0B, so the answer of this question will be AB minus 0, B and A will interchange, and minus 0 minus 0, that is 0. Okay, so the answer is 1 upon AB, B A 0 0. Okay, so this become 1 upon A 0 0 1 upon B. Okay, so this is the answer. This is the formula for 2 cross 2 matrix, finding the inverse of 2 cross 2 matrix, any kind of 2 cross 2 matrix. Okay, the limit x sin x as x tend to 0, as at x tend to 0, that means x sin x, if I will apply L'Hospital rule, then it is a direct formula, x tend to 0. For a L'Hospital rule, x1 sin minus, oh sorry, sin cos x, cos x, cos 0 is 1, 1 upon cos 0 is equal to 1. Okay. Integrating factor of the equation. This is a very common equation. Integrating factor is equal to e की power p dx. Okay. Curl of a vector. So curl of any vector is equal to I j k del by del x, del by del y, del by del z, or putting these values y y z, y y z. So you'll get I 0 0, 0 minus 0. Okay, j is minus 0. This will now 0 0, 0 minus 0 plus k 0 minus 1. Okay, so minus k. Okay, is the curl. The solution of the differential equation. So this is, we have this differential equation. So right is like d square plus 5d plus 6 y can be written as m square plus 5m plus 6 is equal to 0. So m square plus can break as 2m plus 3m plus 6 is equal to 0. Okay, so m plus 2 plus 3 m plus 2, so m is equal to minus 2 and minus 3. So the solution of this equation, y is equal to c1 e की power minus 2x plus c2 e की power minus 3x. Okay, so this is the solution. Okay, Solvay process is for soda ash. Phthalic anhydride is produced by the oxidation of naphthalene. Which of the following fuels has the highest calorific value per unit mass? Natural gas. Okay, the most widely used coagulant, alum always. The shear stress rate relationship for liquid whose apparent viscosity decreases with shear rate is, okay, this is an important concept. We'll discuss. Sorry, we'll discuss here. Okay, So we know that tau is equal to mu du by dy की power n for non-Newtonian fluid. Non-Newtonian fluids. ठीक है, for Newtonian fluid n is equal to 1. We can write as equal to, actually this is not mu, this is k. Okay, so k du by dy n minus 1 into du by dy. Okay, we have separated out 1 du by dy, so n minus. Okay, now this is apparent viscosity, k du by dy power n minus 1. Now this is apparent viscosity, in which this is called apparent viscosity, this is flow consistency index, and this n is called flow behavior index. Flow behavior index, because on the value of n, whether n is less than 1, n is greater than 1, we will tell whether the flow is dilatant, flow is pseudoplastic. If n is equal to 1, flow is Newtonian. Okay, so apparent viscosity and du by dy. So if I plot apparent viscosity will be du by dy, then this is Bingham plastic, this is Newtonian, this is pseudoplastic, and this is dilatant. Okay, if I plot tau versus du by dy, tau versus du by dy, then Newtonian, Bingham plastic, pseudoplastic, and this is dilatant. Okay, so for n greater than 1 it is dilatant, for n greater than 1 it is dilatant. Okay, for n greater than 1 it is dilatant, and for n less than 1 it is pseudoplastic. Okay, so this is the thing. If n equal to 1 and tau naught is equal to 0, this become Newtonian. If n equal to 1 and tau naught is not equal to 0, then it become Bingham plastic, where tau naught is this. Okay, it is called yield stress. Okay, it is called yield stress. Okay, so these are 4 conditions. What? N less than 1, tau naught equal to 0, n greater than 1, tau naught equal to 0, n equal to 1, tau naught equal to 0, n equal to 1, tau naught not equal to 0. So n less than 1, pseudoplastic, n greater than 1, dilatant, n equal to 1 and tau naught equal to 0, Newtonian, n equal to 1, tau naught equal to 0, Bingham plastic. Okay, so moving to the next question. A Newtonian liquid density viscosity is flowing with a velocity v in a tube of diameter d. Let del p be the pressure drop across the length L for laminar flow del p. That is straightforward. That's simple formula. Del p equal to 32 mu u bar L upon d square. That is called Hagen-Poiseuille equation. If you will remove this 32, then proportionality sign will come. So Hagen-Poiseuille equation. Okay, so L mu v d, this c. Okay, next, Prandtl number. Pimote, Samoma, or Ultima. Ultima. So promote Prendatal, Mo momentum upon thermal. T is thermal. Samoma momentum upon mass. Mo momentum mass. D. Ultima thermal upon mass. Okay. So Prendatal number is momentum upon thermal. Momentum diffusivity upon thermal diffusivity. Okay. For laminar flow of fluid in a circular tube, H1 is the convective heat transfer coefficient at velocity v1. If the velocity is reduced by half, assuming the fluid properties are constant and new convective heat transfer coefficient. Okay, so we have this equation. This is called Cedar-Tate correlation. Cedar-Tate correlation for laminar flow and Ditus-Boelter for turbulent flow. That is a different equation. Result number is equal to 0.23. Reynolds number की power 1/2. Sorry, Prandtl की power 0.3 or 0.4 depending on heating or cooling. Okay, this is called Ditus-Boelter correlation. Okay, just check it once. Okay, we have solved a question on this in 1990 question in GATE 1990. Okay, so we have this equation. So what he is saying, if the velocity is reduced by half. Okay, so velocity is reduced by half. So where is the first thing we will see how h is proportional to velocity. So Nusselt number HL upon K is equal to 1.86 D upon L, Reynolds number rho V D upon mu into Prandtl number. No velocity will come, so it is P. Okay. Since velocity is changing, diameter is constant, rho is constant, mu is constant, pressure is constant, diameter is constant, length is constant. So only V will remain 1/3. And no V will come from anywhere because all are constant. So H is directly proportional V की power 1/3. So H1 is equal to K V1 1/3. H2 is equal to K V2 1/3. K. So I'll solve here. H1 upon H2 is equal to V1 is V1, V2 is V1/2, V1/2 की power 1/3. So H2 is equal to 2 की power 1/2 की power 1/3 H1. What is the value? I think this is the answer. 0.794. Let's see once. Point 0.794. Okay. Next, a metal wire of this dia and thermal conductivity is this watt per meter, not degree, Kelvin, is exposed to fluid stream with a convective heat transfer coefficient watt per meter square. The Biot number. Biot number is metal wire. That is it is a cylinder. Biot number equal to HLC upon K, where H upon K, LC is the characteristic length for cylinder. It is R/2. Okay, H. So H is 1000. R is R/2, not D/2. So remember, we have D. So D is equal to 0.01. R is 0.01/2. So 0.01/2 into 4 divided by K is 200. So this will be the Biot. 0.0125. So C is correct. Okay. Diffusion coefficient in binary gases mixture at low pressure varies. for gases. So diffusion coefficient for gases is given by Wilke and Chang relation. Wilke and Chang. What is this relation? DAB is equal to 10 की power minus 4 1.084 minus 0.249 1 upon MA plus 1 upon MB T की power 3/2 under root 1 upon MA plus 1 upon MB divided by PT RAB square and E RAB square function of KT EAB. Okay, so where this is collision function, this is molecular separation, this is total pressure, this is absolute temperature, molecular form weight of A, molecular weight of B. So we have our business with only P, so inversely proportional to P. Okay, so this for gases, and for liquid we have the Wilke and Chang, and another relation for liquid DAB is equal to 117.3. If I am not wrong, just go through that Tribal book, you will find out. IMB 0.5 into T upon mu nu A 0.5 0.5 or 0.6, I think 0.6. Just go through one. Okay, so this is association factor, molecular weight of B. This is absolute temperature independent of pressure because it is liquid, right? Mu is solution viscosity and V solution viscosity, solute molar volume. Okay, so this is Wilke and Chang relation for liquid. This is Wilke and Chang relation for gas. Okay, mass transfer coefficient K according to penetration theory varies with the mass diffusivity 0.5. That is understood. For a gaseous section 2A that gives V, where feed consumes 50 mole% inerts, the expansion factor. Okay, I will not solve this question because I have solved these type of question twice, like 2-3 times. So it is very simple and straightforward. You solve it easily. Okay, I think this is the answer. Among these two, one is the answer. Okay, to maximize the formation of R in the simultaneous reaction, to maximize the formation of R. Okay, so very first we will go for the R upon RS. Okay, so 2Ca 0.5 Cb square upon 1.5 Ca Cb. So CACB, so it will give CB upon CA 0.5, right? So high CB, low CA to maximize the concentration of R. High CB, low CA. B is the answer. Okay. Ideal gas law is applicable at. Always remember, ideal gas law has the condition opposite to the absorption. Absorption has low temperature, high pressure. Low temperature, high pressure. So ideal gas is high temperature and low pressure. High temperature and low pressure. High temperature and low pressure. Okay. The second law of thermodynamics states that the energy change of a system undergo any reversible process is zero. It is not possible to transfer. Second law of thermodynamics. The total energy of the system surrounding remains constant. This is. No, ये तो नहीं है. ये भी नहीं. This one. Okay. Fill in the blanks. In the answer book, fill in the blanks. The Taylor series expansion of fx at around x equal to a. You have to write Taylor series here. For a differential function fx to have maximum, Maximum के लिए this should be 0 and this should be less than 0. Less than 0. Okay. M dx by m exact where del m by del y is equal to del n by del x. Straightforward. Integral of x sin x. It is very easy. You can just apply a Eilert rule. X sin x dx. So Eilert algebraic trigonometric. So x integration of sin x dx minus dy dx of x into sin x dx. So you will get, okay. The Green's theorem relates line integral to surface integral. If a is a scalar and b is a vector, then a is a scalar. Suppose a is any scalar quantity x and b is a vector. B is equal to ai plus bj plus zk. If I multiply x, then it becomes axi plus bj, no sorry, bxj plus zxk, and again we are taking gradient. So del by del x I plus del by del y j plus del by del z k into this whole quantity. So I and I become 1, so it will be a scalar quantity. Okay, so scalar. Not wanting, the question is not wanting answer. It will be a scalar quantity. The differential equation with condition y equal to 0 is called the initial value problem. Okay. Double contact, double absorption, DCDA, H2SO4, one of the most famous process of chemical technology. For an orifice meter, the pressure recovery is then for a smaller than 1 centimeter. This is outdated question, no need to. According to film theory of equimolar quantity, mass transfer coefficient is film theory. Na is equal to dAV upon del C. Mass transfer coefficient, this dAV upon del. The Reynolds analogy for mass transfer is given by and is applicable when Schmidt number is equal to Reynolds analogy. Schmidt number equal to 1. Reynolds analogy, I have told you in previous lectures in 1990 or 1991. Reynolds analogy is F by 2. This is Fanning friction factor is equal to F by 8. Darcy's friction factor is equal to Stanton number is equal to Schmidt number. It can be written as Nusselt number upon Reynolds number into Prandtl number, or it is written as Sherwood number upon Reynolds number into Schmidt number. This is Reynolds analogy. Sherwood number of flow in a pipe or flow in a pipe can be expressed as the ratio of concentration gradient at surface to overall concentration gradient. Similarly, Nusselt number can be related as Sherwood number with the analogy. Arrhenius equation for the temperature dependency of the reaction rate constant is Arrhenius K equal to K naught e to the power minus E by you have to write Arrhenius equation E by T kind of things. For given conversion and a first order reaction, the volume required for a mixed flow reactor is always larger. This question asked in 2014, GATE 2014, IIT Kharagpur. The rate of a reaction is defined as rate of a reaction minus RA is equal to KCA to power n, where n is the rate. The phase rule is given as F is equal to C minus P plus 2 minus R minus S, where component phase plus 2 is for temperature and pressure, R is for reaction, S is for special environment like vacuum. Okay, So we can F is equal to, we will talk a little bit more on this. F is equal to C minus P plus 2 minus R minus F. So this is for component, this is for phases, this 2 is for temperature and pressure. Okay. R is for number of reaction if you have any in the system, and S is for special condition like vacuum or something they will define in the question. Okay. Now match the item in the left column with appropriate item in the right column. Cause hyperbolic. Hyper always comes negative. Cause S will come. So S upon S square minus A square. Sine 80. Sine. Negative will come. A will come. So this. Just check it once. I might be wrong. Okay. I just not gone through maths for since a very long time. Okay. Catalytic cracking, gasoline, catalytic reforming, aromatics. Concentrated sulfuric acid. Not need to. Hydrogenation of nickel, ammonia synthesis, iron. Water gas shift reaction, CO2, CO2. This is water gas shift reaction. It conduct in ammonia industry, because CO is catalyst poison. So it converted to CO2. CH4, H2, CO2 is a water gas shift reaction. Okay. Stanton number, Prandtl number, you know. Weight is rho GV, buoyancy force rho S VG. This will we will see later. Very good questions will come in later. So Nusselt number, Biot number, you know. Nusselt number is fluid upon fluid. Biot number is solid upon fluid. Means Nusselt number is fluid convection resistance to fluid Nusselt number. See. Nusselt number is HL upon K. I can write this L upon K, 1 upon H. Okay, this is resistance for conduction. So conduction, uh, liquid conduction resistance upon fluid convection resistance. So fluid will come. Fluid conduction resistance to fluid convection resistance. Okay. And Biot number is HLC upon K, LC upon K upon 1 upon H, solid upon fluid. Solid conduction resistance upon fluid convection resistance. Okay, so this is the difference. Critical thickness of the insulation for cylinder H by 2 sphere, for sphere 2HK by 2K by H, cylinder H by K. Diffusion coefficient compared to gases and liquid we have just discussed. Schmidt number and Lewis number. Schmidt number is Samoma, Lewis number is Ultima. Okay. These questions are very the rate of A that is B that is C, A plus B that is 2. The rate of the reaction. CV shows the maximum. This is one. CV shows maximum bit time because this will be the graph. CA's concentration will be this CA not CA CB. After some time it will decrease to, and CC concentration of C will go like this. Okay, CC. So this is first, and then This is second. DHDG. Okay, this is important for any cyclic process, for any adiabatic process. For any adiabatic process, P is equal to 0. For any cyclic process, del U is equal to 0. We will not solve this. Very easy question. We will solve this in section B. Okay, this question. So now this question. So we know that H is equal to U plus PV. DH is equal to DU plus PDV plus VDP, right? DU is equal to DQ minus DW. Uh, first law. If I substitute this, DH is equal to DQ minus DW is DQ minus PDV plus PDV plus VDP. So this will cancel out. So DQ is TDS plus VDP is DH. So DH is TDS plus VDP. This is, and G is equal to H minus TS. DG is equal to DH minus TDS minus STD. DG is equal to, if I replace this DH with TDS, this plus VDP minus TDS minus SDT. So TDS cancel out. DG is equal to VDP minus SDT. So VDP minus SDT. Okay. So this is all about section A, guys. We'll solve section B in a single video. And so if you have any kind of confusion, anything, or if I'm not able to explain any question well, so just comment it below. I'll try to share my notes as well. Okay. So take care, guys, and bye, guys.